Hey, David Rathhoff here. In this video, I'm going to be talking about what testing is, the benefits of testing, and how you can get started doing it. Now, you can make testing a pretty complicated process, but really what it's all about is you want to be able to prove that the code that you're writing is behaving in the way that you expect it to behave. And more importantly, that it's working well with other existing code. And if you're making changes to code that exists, that you're not breaking the expected behaviors of that code. And it works at a lot of levels. It can work on, as you're writing like one small piece of code, making sure that you're really just focusing in on one thing at a time and making sure you get that down and before you move on to the next thing. It can work, if you're like pairing with somebody to serve that same purpose, where if you're both looking at a piece of code, you can really focus in on just like one small problem at a time. And then if you're working on a larger suite of code and you're making changes, you can make sure the change you're making here isn't affecting code over here and causing it to break. And then if you're working in teams, a very similar benefit there. And then if you have some kind of system for doing releases or builds of your software, you can show as you make changes, even if the tests are passing in your area, that they still pass somewhere else, or that they still pass everywhere else. And if they don't, you can fail the release or the build or whatever it is. So it has benefits in like at the micro level and the macro level. And I think it's a good practice to start thinking about just right from the beginning as you start coding. You'll probably see, if you were to search about this, that there's a lot of information on testing, but I would really recommend just starting with the simplest way you can do it, which is basically just writing like equals equality statements or equality checks in your code. So I'm going to just do a quick demonstration of what this looks like before I go on about this too much longer. So I'm going to share my screen here. I'm going to shrink this video down slightly. And if you haven't seen this before, I covered this a bit in earlier videos, but if you just want to get to a point where you can write some software really quickly in a given language, this website's really good for it, REPL.it. Supports all kinds of languages. I'm just going with Ruby because it's a language that I'm pretty fast in, and I can demonstrate how this works pretty quickly. So let's just assume, this is obviously kind of a goofy, trivial example, but let's assume we wanted to write something that can just add two numbers together. But we want to show that it's behaving the way that we are expecting it to behave. So before we even start writing the implementation of it, we could just do something like, we could say, well, we're going to have something called maths, and this pane that I'm typing in over here is where you're going to write your code, and then the pane to the right of it is where we're going to see it run. So let's say we want to have something that's like maths.add, and we're just going to add 0 and 0, and we expect that to equal 0. I'm going to go ahead and do a puts on the front of this, put string, which should just show, it should just print out whether this is true or false as a string. So we're going to go ahead and run this. And now you might be thinking, this is ridiculous. Like, this thing's going to fail. Like, we haven't actually written anything to make this thing work. But that's a good thing. And I'll show you why here in a second. So basically what's happening is the Ruby is telling us what we're missing, right? So this isn't working. So on the right, it's saying uninitialized constant maths. So that's letting us know that it doesn't know what maths is. So we're just going to fill that in here. And don't worry too much about the specifics of how Ruby works here. This applies to really any language. You can use this approach. So in order to let Ruby know what I'm talking about, I'm going to make this module called maths, and I'm just going to run this again. And what we should see is we'll still get errors, or we'll still get an error, but it won't be about maths. Great. So this time we're getting an error that's saying undefined method add for maths module. So it's found the maths module. It just doesn't know what this add thing is all about. So I'm just going to go ahead and add. I'm going to go ahead and write in a method for this. And we'll just go ahead and give it two operands here. And again, we're just going to do this small change, run it, and it's still going to fail because it's not going to, doing this is not going to return 0. And that's fine. We'll go ahead and run it. So now you can see we've progressed further. We're not getting an error with the way the code's written itself. We're getting an error with the value that's returned from this. So by default, nil is just going to get returned from this method. If you don't know what nil is, that's fine. It's just basically we're not getting this 0 that we're expecting. So that's cool. We know that this is failing now because we're getting this false. And if we want to prove that the code that we're writing is going to make it work as expected, we could just go ahead and do a return 0. So that means whenever we call add, regardless of what we pass in, it's going to return 0. So that'll make this work. So I'm going to run this again. And you can see here, now we're getting true instead of false. So our test is passing. So we know that if all that mass.add ever has to do is take 2 arguments and always return 0, it's working as expected. Now, that's probably not the way we want add to work. So I'm probably going to make some changes here. So what we could do, we could just jump in and do it. I mean, obviously, you want to just add A and B together, right? But we could write a test first instead. So we could say mass.add, and we could do 2 plus 2 basically equals 4. And now when we run that, we're going to get a false. So this test case isn't working. And if we want to make what this will do is set us up so that when we do make the change, the easy change to add A and B together, we can see that that's working as expected. So we'll go ahead and do, we can leave this in here for now, return A plus B. And I'm going to run this. And we should see both of those pass. So now we have true and we have true. So both of these cases are passing. And we could do something like maybe it's not always clear that maybe there's something going on with like absolute values or something that you want to do. So maybe we just want to say -2 and -2 when added together should be -4. And when we run that, it's going to be true. So we're not getting back like an absolute value or something like that. And this is kind of cool because if you come in and you're you either haven't looked at this for a while or this is code you're handing off to somebody else, they can come in and they can see exactly what you're expecting to have happen. And if they make a change, like if they accidentally add 1 to the value for some reason, then they're going to see all these tests are going to start failing, right? And with something this small, it's kind of easy to spot what the problem is. But as your software gets bigger and more complicated, it's not always easy to figure out what the problem is. And something like this can really help you see one thing that you have a failure, and also a common practice would be to do something a little more explicit here. So like instead of just returning false and true, we might say like adding 0 and 0 returns 0, and then we may just evaluate this whole thing here just to give you an example. So I'm going to run this, and now instead of just getting true and false, we're getting a description of what the behavior is that we're expecting, and it's letting us know if that's true or if it's false. So if you run a bunch of tests and some of them fail, it's always helpful to know exactly which behaviors are failing, and especially if you're working in a language where you don't really get useful errors. It could just say like exit code 0 or whatever. Having these descriptive names for each of your tests can really help you figure out like what's not working as expected. So yeah, I think this is a useful exercise as you're as you're starting out learning a code, and even if you're experienced, like super experienced, this can force you to really focus on one thing at a time and make sure you get that working before you move on to the next thing, because it's always tempting to do the general solution or do the more complicated thing like right out of the gate. If you're working on a big project or you're working with a team, It can help you spot places where you've made changes that are unexpectedly causing things to fail, and areas you may not be expecting them to fail. And then if when you're getting to the point where you're doing like software releases or builds, it's going to show you right away that you have a problem, and you can decide what to do about that. It usually means not doing a release or failing the build, or whatever it is you want to do. But yeah, this is a good skill to, this is a good mindset and also a good skill to kind of build just along the way. So yeah, thanks for joining me in this video. If you're interested in more videos on kind of getting started with programming and coding, and learning some things that you should be kind of thinking about along the way, hit that subscribe button. If you like this video, hit like, and thanks again for joining me today, and I'll be doing more videos like this, so stay tuned. If you're interested in seeing more videos like this, please click the subscribe button down below to be notified about new videos. Also, if you're interested in helping out the channel, I have links in the description to my Patreon page, as well as Amazon links to all the gear that I use to make these videos. Thanks for watching, and I'll see you in the next one.